Hi, welcome to my latest FAQs video. In this episode I'm going to be doing some more ecosystems questions for year 9, but this time with a focus on hot deserts. So Harry wants to know, what is the average precipitation a year in a hot desert? I'm going to talk quite broadly about climate here, so hopefully Harry will answer your question here as well as give you some more information about hot desert climate. As with many discussions about climate, we look at averages, but these figures hide the extremes for which many environments become famous. I'm not going to talk about the absolute record holders with any kind of authority here, as I'm sure that some research you did could debunk any assertion I'd make and you'd find somewhere else that holds a slightly different record. So I'm going to talk about a range of examples, talk about desert climate, and basically these are widely accepted to be the driest, the hottest and the most extreme places on our planet. Let's first take a look at some typical examples of an average hot desert climate. So firstly, Salah in Algeria in the Sahara Desert. Here the temperature can exceed 45 degrees Celsius on the hottest days, and it falls as low as kind of 4 or 5 degrees on the coldest nights. In terms of rainfall, Kuwait in the Persian Gulf has not a single month where the average is more than about 25 millimetres of precipitation. To put that into some kind of perspective, in the UK our driest month is about 50 millimetres of rainfall, as double that of Kuwait's least dry month. More than that, Death Valley might only get 200 millimetres of precipitation in an entire year, so hot deserts are exceedingly dry by any measure. From my research, the driest place on Earth seems to be the Atacama Desert. The typical annual rainfall in this place is just 15 millimetres. Some places here receive as little precipitation as 1 millimetre per year, and I've seen some records say that there may not have been rainfall of any magnitude in the Atacama for centuries. According to worldatlas.com, some sites in the central part of the desert have gone 4 whole years without rain, and that's the most kind of concrete evidence I can find for the assertion this is the driest place on the planet. In terms of record temperatures, in July 1913, some observers in Furnace Creek in California, that's in Death Valley, watched the thermometer reach 56.7 degrees Celsius, and they declared it the highest temperature ever recorded on Earth. But just 9 years later, in September 1922, a weather station in Libya recorded a temperature of 58 degrees Celsius. According to World Meteorological Organization, that remains the highest air temperature ever measured. So there's two competing kind of theories, which alludes to what I was on about at the start. So although the world's hottest place, or the record for the world's driest place, are hotly contested, if you'll excuse the pun, these places do all have one thing in common, and that is that they are in hot desert environments. Some want to know about plant species in hot deserts and how they are adapted to survive in this environment. The harsh and inhospitable desert environment requires plants to adapt uniquely to their surroundings. That intense heat and dryness that we talked about in the last question are just one problem they face. There's also a rapid change in temperature between day and night, and plants have to overcome those challenges to avoid drying out, to avoid overheating, and to avoid freezing. All of that is involved with moisture loss and the need to capture moisture on the rare occasions that rainfall happens, on the rare occasions that these plants have to access water. So desert plants have adaptations that are found nowhere else in the world. We can't talk about desert plants without talking about cacti. They're the archetypal desert plant. There's around 1,700 cactus species, and what they have in common is spines in place of broad leaves, and the fact that they store water in their stems and branches. Those spines perform a number of roles that aren't entirely understood. It's believed they provide some shade, and that shade can actually help moisture condense close to the plant so that droplets of water can form that roll off the plant and can be absorbed through its roots. Thus, obviously, the simple ideas about the plant being protected by attack from herbivores, and actually water may form up to 90% of a desert plant's total mass, but because of the variation that happens between periods of drought and periods of plenty, the stems of many cacti are fluted or ribbed. They've got these textures on them that allows the stem to expand and contract as it gains and loses water. Many desert plants have glossy or waxy coatings to prevent water escaping and to allow it to flow easily down the outside, down to the ground. That means that there's less water sitting on the surfaces of the plant and being lost to the atmosphere through evaporation. Some plants have extensive horizontal root systems that stretch out over a wide area just under the surface, but others have exceedingly long tap roots to access groundwater perhaps as deep as 7 to 10 metres under the surface. Like most desert plants, cacti lay dormant for staggering periods of time. It could be years over the course of which they complete their life cycle, because they have to wait for sufficient water to become available so they can generate the seed pods, generate the flowers that they need to reproduce. So they use a modified form of photosynthesis that produces energy more efficiently. It's for this reason that the classic picture of a Western film style cactus is one that probably exceeds 200 years in age. So these cactuses that may be 10 to 15 feet high actually are the same kind of age as a 100-foot oak tree in a park in the UK. In the Atacama Desert that we discussed in the last question, some of the species include saltgrass, ilareta, thyme, and in fringe regions with some sufficient humidity, there are some more leafy trees like the pimienta and the chanar as well. The Atacama is home to various cacti species. Cardan and candelabro are two, which grow to a diameter of about 70 centimetres and top out at a height of around 7 metres. So for plants, not that big. What this tells us though is that even on the very fringes of existence, life does find a way. Thanks as always for tuning into my FAQs. I look forward to speaking to you again very soon when we'll have some questions from Year 10 on the topic of resource management. Bye for now.